Hi, my name is Carolyn Bernier, and welcome to this tutorial on semantic interoperability for digital product passports. This is actually a second recording of this tutorial. I published the first version about a month ago, and I received so much feedback that helped me improve the content of this tutorial that I decided to make a second recording. Also, the topic of semantic interoperability is a field where I'm learning every single day. I'm not an expert myself on this topic, and it's quite a complex topic. And so, in this video, I have added things that I've understood since the previous video. So, I'm going to share my screen with you so that you can see what I'm doing and what I'm talking about, and be showing some examples. All right. So first of all, just to introduce myself, I'm a research engineer in CEA. CEA is a French public research institution, and I am based in Grenoble. And I'm also the coordinator of the Surpass 2 consortium. I also coordinated the Surpass 1 consortium. Both of these consortia were funded by the European Commission's Digital Europe program. And basically, what we try to do is we try to support the European Commission in building consensus on a standards-based DPP system. And now with Surpass 2 is deploying at scale digital product passports in 4 target value chains to demonstrate data-enabled B2B activities that promote circular economy. And in order to do this in Surpass 2, we have 13 pilot ecosystems that are addressing a wide variety of product groups and use cases, of course. And the reason why we have so many different product groups is that we want to demonstrate that the standards on which the DPP system will be built can apply across sectors. So I created this presentation because semantic interoperability is a complex topic and it's little understood. And in my opinion, I think it's really important for digital product passports for the EU, but also outside of the EU. However, over the last 4 years, I've worked with about 15 or so semantic interoperability experts, and they're very hard to understand. And it took me a long time to put together the bits and pieces of, and the science also, and the practice of how semantic interoperability works in the real world and why this matters for digital product passports. So, first of all, I want to make a disclaimer that the information I provide in this presentation is for information purposes only, and sometimes it's only my own personal opinion. The Surpass 2 consortium partners are not responsible for any damage that could result from making use of this information, and this information should not be interpreted as representing the views of Senelec JTC 24, which is the standardization body currently designing standards for the digital product passport in the EU, nor of the European Commission. In Europe, I strongly encourage everyone watching to join their respective national standardization bodies in order to contribute and be informed of the status of the ongoing work in Senelec JTC 24. So I'm going to talk about the many DPPs problem. So what we observed during the Surpass 1 project is that today many brands are already deploying DPPs or what looks a lot like a DPP voluntarily. And they're doing this because they use it as a tool mostly to communicate with their stakeholders or their consumers, etc. So this is the situation we have today. Europe is introducing mandatory digital product passports for certain product categories. And so, possibly, this will make some voluntary DPPs become mandatory DPPs in the future. So, in order to merge the two requirements, meaning the voluntary DPPs are the ones where brands are actually wishing to share information with their consumers, with the regulatory DPPs, which is a set of data that is defined by law, uh, the in order to avoid putting several data carriers on products, we really lobbied during the Surpass One project to ensure that the European Digital Product Passport is not only a regulatory tool, meaning that the European Digital Product Passport can also be used as a tool to transport voluntary information, meaning informations that brands actually want to share with their stakeholders. But what we see now is that there are other voluntary DPP schemes, for example, being developed by UNECE, and we more and more seeing other states looking into mandating mandatory DPPs for certain product categories. And here I am Canadian, so I chose the Canadian flag here. But you can change this flag and use Turkey or Vietnam or China or whatever state that might be in the future looking to deploy mandatory DPPs for their internal markets. So, um, so this could be a problem, but it doesn't necessarily have to be a problem for brands that sell into different markets because you could resolve to whatever is the mandatory DPP in whatever market you're selling your product into. So the fact that there will be likely mandatory digital product passports in different states is not in itself a problem. However, what I do want to talk about is the fact that the I might be receiving a passport from a given state or a voluntary passport if I'm using the UNECE scheme and I want to reuse data from it. Okay, so so basically, if I here made use the bag. I describe the digital product passport like a brown paper bag. And basically, a passport is just data about a product. And I'm getting this DPP from a given state, and I need to know what this bag of data contains, right? And uh, so, how can I do this? So, in order to do this, I need to be able to understand what this data contains. And this is where semantic interoperability happens. It comes into play. So, semantic interoperability is the ability of computer systems to exchange data with unambiguous shared meaning in one self describing information package that is independent of any information system. This is very important because the economic operator that created a passport somewhere in the world has no way to know what is the information system that will be used to read the passport when once the passport has traveled all over the world, right? So in the European interoperability framework, semantic interoperability is is defined above different layers of interoperability, which include legal, organizational, and technical interoperability, which sometimes includes syntactical interoperability. So, syntax is the grammar and the format of the files that will be exchanged, like XML or JSON, etc. But syntactical interoperability is not sufficient. We need to semantic interoperability goes further by making the meanings of the data elements explicit and the relationships between these data elements. Most of the time, in most DPP schemes I've seen, semantic interoperability is ignored because Often, it's assumed that the meaning of the data field will be self evident from the name of the property. So, this may be true in some restricted contexts when people share the same understanding of what a term means. But if data travels all over the world, this is no longer true. For example, you take the term battery life. There could be possibly dozens of different definitions of what this term actually means. So, semantic interoperability means that the meaning of the term will be made explicit and will be contained with the data. So, as I said, the DPP is going to travel with products all over the world. And I have no idea who is going to use this data, whether it's going to be a public administration, if it's going to be customs, if it's going to be a repair shop, a consumer, or some factory someplace, right? So the meaning of the data has to be correctly conveyed. So, what I've seen is that most DPP related initiatives ignore semantic interoperability because they work in relatively small and closed ecosystems. To the best of my knowledge, there are three approaches today that are being actively investigated that thankfully no longer ignore the need for semantic interoperability for digital product passports. So there's the link data approach that is being developed by UNECE, but also by Surpass project, the OntoDecide project, the Seneca project, etc. There's the DPP 4.0 approach, and there's the construction sector approach. Okay, so we're going to go into details later on in this presentation. So this is a very good news that there are there initiatives that are not ignoring semantic interoperability. Okay, so now I'm going to dive into the ingredients I need to make semantic interoperability happen. And to understand what this bag of data contains, I need to know how the data is structured and what is the meaning of each term used. So we're going to go into the detail of these two things in the following slides. So let's start with how the data is structured. So I took this figure from this textbook written by two experts on semantic interoperability. And what they describe in their figure here is that there are four popular ways to structure data, and each one has pros and cons, and each one has been developed in specific contexts. And so there's no one that is better or worse than another, etc. Each one is perfectly fine in the context for which it was developed. So here, the first one here, tabular data, it's if ever you've designed an Excel spreadsheet, then you know what this way to organize data is all about. So I won't go into details. Relational databases are made using this model here, where the data is structured as different tables. So it's like an expanded spreadsheets. You have spreadsheets of spreadsheets that are linked together. Okay, so this is an extremely popular way to model data in relational databases. Another popular way that was popularized through XML is using the meta markup language, which have a hierarchical structure. Okay, so each child concept can only have one single parent concept here, and there's exactly one root element. And finally, the RDF approach. So RDF stands for Resource Description Format. Uh, it uses uh, data that is linked through a predicate here, which is a property, okay, which links different concepts. And so you have this directed graph of a subject, a predicate, and an object. And these and an object can become the subject of another predicate, etc. So here, this is another way to model data that it uses a graph representation and can take any shape. So basically, you could take a model from any one of these approaches and transform it into a model in any other one of these approaches. Okay, so they can be more or less equivalent. The only one that cannot necessarily always be transformed back is the RDF, because you can have circularity in approaches in a graph, which you would not be able to model using the other approaches. But otherwise, you can think of them as more or less equivalent. Um, okay, and another point before I move on, and this created a lot of confusion for me, was that RDF is both a methodology for modeling data, but it's also a serialization format. So this created a lot of confusion for me in the past. The thing is, depending on which approach I use, if I want to send data to someone, they will have to understand how this data is structured. So, if I use any one of these three approaches, I will have to define a standard or a technical specification explaining how I have decided to structure the data. Okay, so, and every time I'm going to change my data model, I'm going to have to create a new standard. Okay, this is different for the RDF approach because the standards used to model data have already been defined by W3C. And if I expand my data model by adding nodes in the graph, for example, I do not need to create a new standard. Okay, so now I am going to move on to the second part, is how the meaning of each term is defined. Okay. So, in the field of semantics, the terms that I will use are the vocabularies. And this terminology has to be very clear. Terminology, we have to agree to use a specific term that has a specific meaning in order for the meaning to be conveyed clearly. So I will need terminology, specifically clear terminology, to describe all of the concepts that can be classes, properties, value lists, values, relations, all the concepts that I want to model. So for each term in my vocabulary will have an associated definition, ideally provided in multiple languages. And because I'm sending the data all over the world, these definitions must be publicly accessible for lookup. So I will talk a lot in this presentation on about the two major approaches for defining vocabularies and their associated definitions. The first one is through the use of controlled web vocabularies, which are used typically in linked data. And the second approach is by the use of standardized dictionaries. Because they're basically modeling a concept, you could use either one to model the same concepts, okay? So it's not difficult to transform one into the other. It's mostly formatting issues, as I will describe in the future in this coming slides. So I'm going to start with so before going in deeply into describing what is a controlled web vocabulary, I want to just state that they while their goal is exactly the same, they do differ in how the terms are made globally unique. So the terms need to be globally unique because I'm sending my DPP uh, halfway around the world, and when the recipient of the data retrieves some term, they need to look up this term in a globally unique way. The two approaches also differ in how the terms are conceptually structured, okay? Because there's a relationships. There are always relationships between the terms. So so there is a structure in how these concepts relate to one another. They differ in how the terms are stored, and they differ in the manner in which they encourage reuse and redistribution of the terms, and they differ also in their support for formal reasoning tools. However, what I want to state is that in both cases, defining these vocabularies is a job for experts. And this is very hard work because not only you have to know how to properly model things, but second, you have to reach consensus on the use of a specific term for a specific concept, right? So this is a long and costly work. So, any existing and well defined vocabulary is therefore a very valuable tool. And it's because defining vocabularies is a very costly process that most people don't bother. And they really hope that the definition will be clear from the name of the entity or the property. So, I'm going to start with the first category. And I'm going to talk about controlled web vocabularies. So, same as for dictionaries, controlled web vocabularies define concepts and the relationships between the concepts needed to describe a field of interest. So, I'm going to define all the terms for all the classes and all the properties that I will need. It is common practice to use what is known as cool URIs to build controlled web vocabularies. And a cool URI is basically a URI which will not change, and it will not change for the next 100 years. So it really will not change. And the reason we need it to not change is that uh, I don't know who or when this data will be used by whoever will get it. And when they do get it, they need to be able to access that definition. Often, but not all the time, controlled web vocabularies are organized using an ontology. And here I'm going to introduce a very complicated definition. So, an ontology is a formal specification of a conceptualization in a domain. So, this is a very complicated definition, but what it says is that it it's a formal specification, meaning that it uses a standard, it refers to a standard of a conceptualization. So, a conceptualization is basically a model of all the concepts that I need to describe the field of interest. And the domain is the field of interest. In the linked data world, the ontologies are modeled mostly using OWL. So, OWL is the ontology web language, but there are many other ontology description standards that exist. So a few examples of controlled web vocabularies. I took them from the European Commission's core public organization vocabulary. And what you can see here is that whether or not the terms represent class objects or properties, they are more or less structured exactly in the same way, except that you have capital letters here for classes and non-capital letters here for properties. And they are very cool in the sense that they're very short. And they reference here a domain name, and this is the namespace for this specific vocabulary that is defined here. And thanks to the use of this domain name and the management of this domain by the Commission, I know that this term will be globally unique. So the Commission here has decided to organize their vocabularies in an ontology, and which can be downloaded here. And we're going to take a look at it. But before I look more into these terms, I'm going to just give a few more examples of cool URIs that for vocabularies that come from schema.org. And so here we have again the domain that authorizes global uniqueness, very, very short URIs and very clear URIs. Um, so each one of these vocabulary terms links to both a machine readable and a human readable presentation of the definition that I need, but it will also include the concept inheritance information that structures the different concepts, and also the properties of each concepts. It's the ranges authorized for each properties, usage notes, and all sorts of things. So if I, for example, look at this term, and because I'm a human and not a machine, it redirects me to this very nice human readable definition of this term, um, and where I can read the definition, some usage notes, and it tells me how the concepts are organized and the properties for this term, for this class, and the range of each one of these properties, etc. But this is because, of course, I'm a human. If I were not a human, it would have led me to some machine readable place. Let's take a look at it. So here I'm going to look at the ontology file in the turtle format. So the turtle format is pretty neat because it's easy to read for a human. So it starts with referencing all of the ontologies and vocabularies that are being reused by this ontology. And here I have the machine. What I saw previously was a human rendered definition here. So this data that I accessed previously as a human, and it gives me all the information that I need about that term. Okay. One thing that you will notice is that the there is no organized in this ontology. You see, so here we have other additional classes and properties, and whether they're data types or object properties, and the order in which these different concepts are listed in the turtle file has no importance. Okay, so the order is not important. So if I come back here and I look at another example from schema, this takes me information about the concept structuring and inheritance and the different properties for the given context that I inherit from the different concepts, and examples of use and where this concept is being used, for example. Okay, so this is what a web vocabulary is. So, oops. So what I wanted to observe, what you saw is how so if I recap a little bit, so the terms are made globally unique thanks to the domain name that is mastering that is controlling the URI. And for example, the data.europa.eu. And how the concepts are conceptually structured is using either the vocabulary description itself. We saw that the concept hierarchy is defined there, or using an ontology. But this is not always the case. A very important observation is that the terms are stored in an unordered manner. So, in order to visualize these terms, usually what we see are graph visualizations. So, let me just show you a few of these graph visualizations. So, for example, for this ontology here, this is the ontology that we're building in Surpass 2. I can see the terms. Usually you have this nice graph that explodes view. That's one way to observe the terms. Most of the time, you also have diagrams like this, where the relationship between the different concepts are described. Um, And but what you see is that often, this is another example. What you see is often the concepts are rather graph. They're more like a graph. So a concept can point to another concept and vice versa. And so there are many types of relations that can exist between the different concepts. Here we have an example of another ontology created by the European Commission. It's the European Legislation Identifier. And I just want to show you how here it is reusing concepts that have been defined on schema.org. So concepts such as a creative work that comes with all sorts of properties. And because a piece of legislation is a creative work, it can inherit all the properties of creative work, but legislation has additional properties that are defined in the ontology here. Okay. So now I'm going to move on and I'm going to talk about data dictionaries. So it's very, very similar to controlled web vocabularies. You define the concepts, the relationship between the different concepts, but here you will need a specific standard. And often you will find different standards that are defined in different sectors. So this set of standards are used in the construction sector in Europe. These set of standards are used in the electrotechnical sector, and the way the terms are made globally unique is through a unique number that is often standardized, of course. In the construction sector, they will use a global unique identifier. And in the electrotechnical sector, you use an IRDI. So typically, the concepts are organized or structured hierarchically. They can be flat, but typically they are organized when there's relation between them in a hierarchical manner, using a taxonomy and often using a classification system. And so this means that the terms can be ordered. So let's sh- let's show let's I give you an example from a standardized dictionary, which is the IEC Common Data Dictionary Repository, in which there are many. I'm looking at the Electric and Electronic Components Dictionary that is stored in the repository, which is the Common Data Dictionary, and this is managed by the IEC. And in this dictionary here, um, I see that all the terms are structured in a hierarchical manner. Right? So here you have class inheritance from one term to another in a hierarchical manner. So exactly like we saw previously for controlled web vocabularies, here I have a term which is a differential amplifier, and I can find its IRDI, so its unique identifier. I can find its definition, and I can find the class hierarchy here and the specific properties that are need to describe differential and amplifiers, and all of the properties that I inherited from the class hierarchy. So it's conceptually exactly the same as what I did mention previously about controlled web vocabularies. So, but you will notice though that there is a ordering of the terms, which means that and here you also notice that there is a number that is associated to a specific term. So a classification code is associated to a specific term. So the question I wonder a little bit, that puzzles me a little bit, is what happens when I want to expand on this classification and this taxonomy to include the gazillion different other types of amplifiers that you can find, ultra wideband amplifiers, microwave band amplifiers, terahertz band amplifiers. There's many, many different types of amplifiers you can imagine, and you would want to include in here because of this numbering scheme. This might be a little bit complicated, and perhaps I would need to create another dictionary and reference these terms in order to inherit all of their properties. So when I published the first version of this tutorial, I got a lot of feedback from experts. And basically, the experts I got feedback from more or less commented on this part. This is where the important differences are. And um, so what we see is that here the fundamentally, if I use controlled web vocabularies, the ordering of the terms has no importance. Whereas in the hierarchical approach, it does have importance. We see that this is ordered because all the terms are classed or stored in a little bit like in a file system. So the the ordering is very important, and also the it was stated to me that hierarchy is a form of implicit context. So indeed, when I have a term that belongs to another term, like a class that belongs to another class, so class A is part of class B, or is an instance of class B, or is rather inherits from class B, the hierarchy implicitly also states that A is only part of class B. So so there is some implicit information in the model that is that that is in this is absent from the controlled web vocabulary approach, where the um, relations between the terms is made explicit. Also, I observed that ordering schemes and classification schemes tend to become standards and therefore tend to become competing standards themselves. So I may try to capture what it is that the experts argue about. And so if I come from the world of the controlled web vocabulary approach, the arguments are that classifications and break down in time. So let's avoid using them altogether. Also, another important thing here is that every single relation type must be made explicit. So, for example, the fact that A is only part of B is implicit in the taxonomy, but in the controlled web vocabulary approach, this would be made explicit. And these explicit relations are needed in order to apply formal reasoning tools. And in this community, often it is seen that reasoning is an indispensable tool to check the coherence of a given modeling or conceptualization. What the arguments that you will have in the opposing approach is that classifications and taxonomies are indispensable tools and we cannot do without them. Implicit relations are not a problem, and formal reasoning is not needed because the taxonomy provides this coherence. So I hope I cross my fingers and I hope that I manage to capture what is the expert arguing what they are arguing about. And personally, I do not care because this is this is takes us away from the important thing, which is we do need these vocabularies in order to create DPPs. And as I said previously, both of these representations can be converted into one another. And what really matters is that we have these vocabularies. Okay, so I'm going to leave this debate, between experts, and I'm going to come back to the digital product passport. And as I said before, to the best of my current knowledge, there are three different approaches being investigated to achieve this semantic interoperability for digital product passports. So there's the link data approach being investigated by the UN Transparency Protocol DPP. There's the DPP 4.0 approach and the construction DPP approach. So these two approaches here. They use a hierarchical data model plus external dictionary approaches. So I've already mentioned how the terms are made globally unique. And here I listed all the standards that are needed to describe the data model structure and the dictionary structure and the concepts classification standards and the property description standards and all that, etc. So there are different sectors, and so they use different standards in order to do all of this. Serialization, well, there's several possibilities that are offered. When linked data is used, JSON LD is usually the favorite serialization format. Um, so the important point here is that we the goal here is to reuse existing W3C standards and not to define a specific standard for a specific sector. And so I'm not going to go into detail of all of these standards. You can look them up if you want. There's one important point, though, is that the construction products regulation that was adopted in the EU in the fall of 24 states that a European level dictionary will be required for the construction products regulation. And here we can rejoice and and because this means that the European Commission has decided to adopt semantic interoperability approaches for the construction products DPP. So, summarizing a little bit, semantic interoperability is costly. Let's not try to avoid this point. It's very costly. It's costly because you have to create and maintain these vocabularies, and that's a major difficulty. So, if we exclude public bodies like the European Commission, who has actually managed to succeed in building these vocabularies, well, you have schema.org, which is managed by Google and W3C, and it's very widely used. So we could say that this is a success. And otherwise, you have very large standardization organizations, W3C, Etsy with the Saraf ontologies for IoT applications, GS1, a very large global standardization organizations with EPCIS and CBV, which are now ISO standards. You have ISO with a very recent industrial data ontology, for example, the IEC, like we just saw, then UNECE with the by ship pay ontology, the CUS ontology, and now UNTP, and many others. The important message here is that public vocabularies are a common good, and they are, because they're so costly to create, they're precious resources. So we must find solutions to reuse them as much as possible. So now that I've addressed the very first question on the left, which is how can I know what this bag of data contains, I will move on to a second question is how can I make it easy to reuse data from different DPPs that have been issued by different stakeholders in different states, right? So I basically have how can I deal with this DPP diversity? So I have two options. Basically, I can force the entire world to use the same standards to structure the data and publish the required dictionaries. The question will be, of course, which sector standards will win and which country's standards will win. Okay, so basically, this is a global standardization war. It's not very fun. Another option is to make it easy to reuse data from any DPP issued worldwide. And here is you use W3C linked data standards for structuring the data, and you publish the needed vocabularies as controlled web vocabularies that any stakeholder can control because they control the domain name for each term of their vocabulary. So I defend option two, I think pretty obviously. Linked data has been around for more than 25 years. It was designed from the start to publish data on the web, which is what exactly the DPP is about. It's based on international, well established technical specifications that are widely used. It's already well adopted by industry, and it's also promoted by many public administrations, not only in the new European interoperability framework, but also by US Customs Border Protection and many other states. Um, and then, so how will we deal with DPP diversity? Well, we will use well known and formal, mathematically sound automatic alignment and reasoning tools in order to do this if necessary. In this way, it would become easy to reuse data from any DPP issued anywhere in the world by any stakeholder, and that might be mandatory by any sovereign state. So I want to leave you with these questions on how in the future e- coming ESPR delegated acts for sector specific digital product passports will be transformed into a DPP template. So, as everyone knows, these delegated acts of the ESPR will provide the list of mandatory information requirements for sector specific digital product passports. These information requirements will be written in text, human readable text. So, somehow we have to transform these terms into machine readable terms. So I can only assume that under the guidance of the European Commission, possibly following a new standardization request to a European standardization organization, each textual information requirement would be mapped to a term in a vocabulary somewhere, and ideally referencing as much as possible and in that order public and already available international standardized vocabularies. Like we've mentioned a lot of them. Uh, but if terms are missing, you would reference existing European Commission controlled vocabularies. There are many, as I showed. And in case new terms or concepts are missing from all of those, then a new European vocabulary could be created. In this way, uh, we could give all stakeholders clear guidance on how to build compliant DPPs with machine readable, semantically interoperable data. So, with this, I conclude this talk. Thank you very much for your attention. A huge thank you to the 15 or so semantic interoperability experts that helped me over the last 4 years and more recently in the last month to understand this very complicated topic. I hope you found my talk entertaining, and thanks a lot, and maybe see you next time. Bye.